For decades, Toyota built its reputation on quiet strength, the dependable force behind millions of drivers worldwide, never needing to shout to be heard. But something shifted. In a rare, pointed statement, Toyota's CEO stepped into the spotlight with a message few expected. Our new dynamic force engine will destroy the competition. It was more than a challenge, a signal that Toyota was no longer content staying in the background. So what exactly is this engine? And why is Toyota so confident it will leave everyone else behind? Let's uncover the real story behind Toyota's boldest move yet. The rise of Toyota's dynamic force engine strategy. Toyota is not just improving its engines, it is changing how they work to meet future needs. With its new dynamic force engine series, Toyota is focusing on improving fuel engines while many other companies are switching completely to electric vehicles. These engines are not small updates. They are part of a long-term plan connected to Toyota's global design system called TNGA, or Toyota New Global Architecture. This system helps Toyota build cars that are stronger, more efficient, and easier to produce. While many companies are focusing only on electric cars, Toyota is improving both fuel and electric systems. The CEO of Toyota said that the new dynamic force engines are a big part of the company's plan. These engines are designed to use less fuel, create fewer emissions, and still give strong performance. They can also work with different types of fuel, such as ethanol or hydrogen. Toyota believes that fuel engines can still improve and play an important role in the future of transportation. This choice is based on global needs. In many countries, electric cars are not practical because charging stations are limited and electricity is not always reliable. In those places, efficient fuel engines are still the best option. Toyota is building engines that can work in these areas while also meeting environmental rules and keeping costs low. The new dynamic force engines are designed to work with Toyota's TNGA platform. TNGA is a system that allows different cars to share the same parts and design. This helps reduce production time and makes it easier to use the same engine in many types of vehicles. For example, the same engine could be used in both a small sedan and a larger SUV without needing a full redesign. This system helps engineers focus on making engines better instead of starting from scratch each time. It also allows Toyota to bring updates and improvements to many models more quickly. This approach saves money, reduces waste, and supports future changes, like switching to new types of fuel. The dynamic force engines focus on more than just speed or power. They are built to be efficient, reliable, and better for the environment. One of the most important changes is their high thermal efficiency. This means the engine can turn more fuel into usable energy, rather than losing it as heat. These engines also use a longer piston stroke and a mix of fuel injection methods to improve performance and reduce emissions. Cooling systems are also more advanced. Electric water pumps and better temperature control help the engine stay at the right temperature. This makes the engine last longer and work better in different weather conditions. Every part of the engine was designed with care to support both performance and fuel savings. The Dynamic Force series includes 3 types of engines: a 3-cylinder, a 4-cylinder, and a V6. The i3 is small and uses less fuel, which is good for compact cars. The i4 is the most common type, found in many mid-size cars. The V6 is stronger and made for larger vehicles that need more power. Each engine can work with several types of fuel. Toyota is testing options like ethanol and hydrogen. These engines are also designed to work with hybrid systems, so they can be used in both fuel-only and hybrid cars. This gives Toyota many options when building new vehicles. Toyota builds these engines using its global factories. The design allows for flexible production, so the same engine can be made in different countries with local parts. This saves time and money while keeping quality high. It also helps Toyota deal with supply issues or changing demand in different regions. Because these engines follow the TNGA system, Toyota can quickly adjust production based on local needs. For example, if one market needs more ethanol-based engines, Toyota can shift resources without major changes. This kind of flexibility is useful in today's fast-changing industry. Why this helps? Toyota compete. The dynamic force engines give Toyota an advantage. While other companies are moving away from fuel engines, Toyota is improving them to meet both current and future needs. These engines are ready for multiple types of energy and work well with hybrid systems. This makes them useful in many markets, especially in places where electric vehicles are still not practical. The new engine design, along with the TNGA system, helps Toyota keep costs low and quality high. This means customers get cars that are efficient, dependable, and ready for future updates, all without giving up performance. By using TNGA, Toyota can produce many vehicles with fewer changes in the production line. It also makes it easier to add new engines, like the Dynamic Force series, across many models without changing the entire car. This speeds up development and lowers costs, while still allowing each car to have a unique style and function. One of the main goals of TNGA is to support new technology. That includes not only better safety and comfort features, but also new types of engines. The dynamic force engines are designed to fit perfectly within the TNGA layout. This means engineers don't have to redesign the car every time they improve the engine. This helps Toyota stay ahead in markets where clean energy is growing quickly. By building flexible cars that support different powertrains, Toyota can adjust its lineup without big design changes. This is a major advantage in today's auto industry, where energy systems are changing fast. Several cars built with TNGA and dynamic force engines are already on the road. Models like the Toyota Corolla, Camry, and RAV4 use this setup, and they have seen improvements in both performance and efficiency. Drivers notice better fuel economy, quicker response, and smoother driving. For Toyota, these results show that the TNGA system works as planned. It supports fast changes, reduces production time, and helps introduce new engine technologies across many models. This gives the company a strong position in both traditional and emerging markets. Every major leap in automotive progress begins at the engine. For Toyota, the dynamic force engine represents the next stage in internal combustion design. These engines are not simply a tweak of the past. They are a complete redesign of how power, efficiency, and emissions are balanced. Developed from scratch and built to pair with Toyota's TNGA platform, the Dynamic Force family brings a focus on thermal efficiency, smart air-fuel management, high-speed combustion, and mechanical precision. Toyota's engineers set out to achieve what most considered extremely difficult, increasing thermal efficiency in a gasoline engine to levels typically seen only in hybrid or diesel powertrains. In internal combustion engines, thermal efficiency refers to how much of the fuel's energy is converted into useful work. Traditional gasoline engines tend to have thermal efficiency in the range of 30 to 33%. The dynamic force engines break past that limit, with figures reaching 40% in gasoline-only configurations and even 41% in hybrid setups. This improvement comes from a combination of technologies working together. Instead of focusing only on one system, Toyota looked at how each part of the combustion process could be enhanced. That includes how fuel is delivered, how air flows into the cylinder, how the combustion chamber is shaped, and how heat is managed during ignition. Improving all of these areas led to the record-setting efficiency numbers Toyota now claims. Dual injection system. A major difference in the dynamic force engines is their stroke-to-bore ratio. These engines are built with a longer piston stroke compared to older designs. This geometry increases the compression ratio and improves thermal efficiency. For example, Toyota's 2.5-liter engine has a high compression ratio of 13:1 or 14:1, depending on the variant. Higher compression leads to better combustion of the air-fuel mix, which increases power and reduces waste. However, high compression can also cause engine knock, a problem where fuel ignites too early. Toyota solves this by using better cooling systems, advanced ignition control, and precise fuel delivery. It's a careful balance, more power without damaging the engine. And the engineers at Toyota have made that possible through small, smart improvements across the board. Fuel injection is one of the biggest changes in engine design over the past few decades. Toyota's dynamic force engines use an advanced system known as D4S, which combines both port injection and direct injection. In port injection, fuel is sprayed into the intake manifold. In direct injection, fuel is delivered straight into the cylinder. Each system has strengths. Port injection helps clean intake valves and works better at lower engine speeds. Direct injection improves fuel atomization and power output, especially under high load. Toyota's D4S uses both systems together, switching between them or using both simultaneously depending on engine needs. This dual approach maximizes efficiency and power. It also helps control emissions by optimizing the air-fuel mixture more accurately under different driving conditions. Whether the driver is cruising slowly or accelerating hard, the engine adapts instantly to maintain perf and reduce fuel use. To improve airflow and combustion even further, Toyota uses new materials and machining techniques in the engine head. One example is the use of laser-cladded valve seats. This process coats the valve seats with a layer of durable metal using a laser, creating a surface that is both smoother and more heat-resistant. This improves sealing, reduces wear, and helps maintain consistent combustion over the engine's life. Air intake is also optimized using high-precision machining. Toyota polishes the intake ports with a mirror-like finish, reducing resistance and improving airflow into the cylinders. Smoother airflow means more oxygen per combustion cycle, which increases power and efficiency without requiring a turbocharger. VVT-IE and electric control. VVT is nothing new, but Toyota takes it a step further in these engines. Most older systems use oil pressure to change valve timing. In dynamic force engines, Toyota uses an electric motor for the intake side, a system called VVT-IE. This allows much faster and more accurate control of the valves, especially during cold starts and low-load conditions. Why does this matter? Because valve timing affects how the engine breathes. Better control means the engine can switch between fuel-saving and power-making modes more effectively. It also improves responsiveness and emissions, particularly during stop-and-go city driving. Another key feature is Toyota's new cooling system design. Instead of a single cooling circuit, these engines have multiple channels that target different areas like the cylinder head, block, and exhaust valves separately. This allows the engine to heat up faster when starting cold, and then cool more effectively once it reaches operating temperature. Quicker warm-ups reduce emissions, and precise cooling improves durability and performance. Sensors constantly monitor temperature and adjust the cooling flow to match driving conditions. It's a smart system that helps the engine last longer and work more efficiently in all climates. Friction is one of the silent enemies of engine efficiency. Every moving part, from the pistons to the camshafts, creates resistance that steals energy. Toyota engineers attacked friction in every part of the dynamic force engine. They used low-friction coatings on the piston skirts, roller rocker arms in the valve train, and optimized oil flow to reduce drag on rotating components. Even the timing chain has been redesigned to lower friction and reduce noise. These changes might seem small individually, but when combined across the entire engine, they result in smoother operation, less fuel use, and lower wear over time. The dynamic force engine is built with strict global emission standards in mind. To reduce emissions at the source, the engine uses fast-response oxygen sensors and high-flow catalytic converters. It also places the catalyst closer to the engine, helping it heat up faster and become effective sooner after startup. In hybrid versions, the engine can shut off during low-demand conditions, and the electric motor takes over. When the engine restarts, it does so quietly and with minimal emissions. This is another area where TNGA and dynamic force work together. The platform is built to support both combustion and hybrid setups, and the engine software is tuned to switch between them smoothly. While gasoline remains the main fuel source for most vehicles, Toyota has designed the dynamic force engine to work with other fuels as well. In some regions, ethanol is more common. In others, regulations may require engines to operate with low-sulfur fuel or alternative blends. Toyota has tested these engines with ethanol blends and has confirmed their compatibility with flex fuel systems. Toyota is also exploring the use of hydrogen as a combustion fuel. This is different from hydrogen fuel cells. In combustion hydrogen engines, hydrogen is burned inside a traditional engine, just like gasoline. But the result is water vapor instead of harmful gases. The GR Corolla H2 project is one such example. While it's still in development, it shows how flexible and future-ready the dynamic force engine architecture really is. The backbone of the TNGA strategy. Toyota's TNGA platform has not only improved vehicle styling and rigidity, but also made it easier to adopt new powertrains at scale. Because TNGA was designed from the ground up to accommodate the dynamic force engine family, Toyota can swap in various displacements and hybrid combinations with minimal re-engineering. This flexible architecture has allowed Toyota to integrate the engines efficiently across continents without sacrificing local adaptability or market-specific requirements. This approach reduces development time, cuts manufacturing costs, and delivers a consistent driver experience globally. Whether a customer is buying a Camry in the United States, a RAV4 in Europe, or a Corolla in Southeast Asia, the underlying engine technology remains largely the same: refined, efficient, and future-ready. Some of the first models to receive dynamic force engines were Toyota's most important global nameplates: the Camry, RAV4, and Highlander. These vehicles were also among the earliest adopters of the TNGA platform, making them natural fits for the new powertrains. In the Camry, Toyota introduced the A25 AFKS, a 2.5-liter inline-4 gasoline engine delivering around 203 horsepower and paired with an 8-speed direct-shift automatic transmission. It also offered a hybrid version, rated at 176 horsepower on the gasoline side and up to 208 total system horsepower with the electric motor. The result? Improved acceleration, quieter operation, and a fuel economy rating pushing 50 miles per gallon for hybrid trims, outperforming rivals like the Honda Accord Hybrid and Hyundai Sonata Hybrid. The RAV4 followed closely, also featuring the A25A series in both standard and hybrid forms. For a compact crossover, the dynamic force engine gave the RAV4 a surprising punch. Its hybrid variant became the top-selling hybrid SUV in North America, thanks to its class-leading 40-plus miles per gallon fuel economy and responsive performance. The success of the hybrid RAV4 proved that Toyota could scale this new engine technology without compromising on practicality or reliability. In larger models like the Highlander, the 2.5-liter dynamic force engine powers the hybrid variants, replacing older V6-based hybrids. Despite downsizing, the new powertrain delivers 243 total system horsepower while offering vastly improved fuel economy, up to 36 miles per gallon combined, and meeting tighter emission standards in both the US and Europe. After success with mid-size and SUV segments, Toyota began rolling out dynamic force engines to its compact models. The Corolla was among the most important of these. With over 50 million units sold globally, the Corolla's transition to dynamic force was a major milestone. The 12th generation Corolla uses the M20 AFKS engine in non-hybrid variants and the M20 AFXS for hybrid trims. The hybrid Corolla, already popular in Japan and Europe, quickly gained traction in the US and Australia, offering over 50 miles per gallon with minimal performance trade-offs. Customers noticed quieter engine operation, better throttle response, and smoother transitions between electric and gasoline modes. In Japan and select European markets, smaller engines, like the 1.5-liter M15A FKS and its hybrid counterpart, M15A FXE, have been used in the Yaris and Yaris Cross. Despite their small size, these engines deliver strong fuel economy figures and better driving dynamics, thanks to the lightweight TNGAB platform. In urban centers like Tokyo, Paris, and London, these models became popular for their nimbleness, emissions compliance, and improved mileage, often surpassing 60 miles per gallon in hybrid configurations. Toyota's subcompact crossover, the CHR, also utilizes dynamic force engines tailored to specific markets. In Europe, the hybrid model became a standout success, aided by low emissions and favorable tax treatment under European environmental laws. The 1.8-liter and 2.0-liter dynamic force hybrids offer a balance between performance and efficiency in a stylish, urban-friendly package. While the core technologies remain the same, Toyota has adapted the dynamic force family to meet regional requirements. For instance, in markets like Brazil and India, where ethanol-blended fuels are more common, Toyota offers flex-fuel versions of these engines, capable of running on E85 or similar blends without compromising longevity. In North America and the Middle East, where demand for larger SUVs and trucks is still strong, Toyota continues to pair dynamic force engines with traditional V6 or V8 configurations. But this is changing. The shift toward hybridization in trucks is growing, as seen in the hybridized Tundra, using a 3.5-liter twin-turbo V6 paired with electric motors, part of the broader iForce Max strategy inspired by dynamic force tech. In China, where emissions regulations are tightening, Toyota has partnered with local firms to roll out hybrid models using the 2.0-liter dynamic force engine, tailored for low-emission vehicle classification. Government incentives and rising fuel prices have made hybrids more attractive, and Toyota is responding with aggressive hybrid expansion. Performance cars and Lexus models. Dynamic force isn't just for economy cars. Toyota's luxury division, Lexus, is also benefiting from this new engine family. The Lexus ES250 uses the 2.5-liter A25 AFKS engine, while the hybrid ES300H uses the A25 AFXS. Even performance-oriented Lexus models are seeing integration with modified dynamic force units, tuned for higher output and paired with more advanced hybrid systems. The Lexus UX, NX, and RX hybrids all use dynamic force engines in one form or another. These models prove that high-efficiency engines can still deliver luxury-grade smoothness and acceleration, particularly when paired with Toyota's electric drive modules and Toyota's new Crown, which repositions itself between luxury sedan and SUV, is also powered by the dynamic force-based hybrid system, now paired with AWD and performance-tuned electric motors. It symbolizes Toyota's vision for combining premium styling, utility, and fuel efficiency. Customer feedback has been overwhelmingly positive. Drivers report smoother power delivery, less engine noise, and noticeably better fuel economy compared to previous generations. Repair records and consumer reliability studies show no significant problems so far, which is a major win for such a large engine rollout. Dealers have also noted improved customer satisfaction, especially among hybrid buyers. Toyota's decision to keep hybrid models affordable while improving their range and drivability has widened appeal beyond just environmentally conscious consumers. Now it's also about saving money at the pump without sacrificing performance. Fuel economy ratings in EPA and WLTP testing consistently put Toyota at the top of its class, especially among non-plug-in hybrids. Carbon dioxide emissions per kilometer have dropped across the lineup, helping Toyota meet tightening regulatory standards in the EU, Japan, and California. In a global auto industry charging ahead toward electrification, the question facing many automakers isn't whether internal combustion engines are dying. It's whether they're evolving fast enough to remain relevant. Toyota has answered that question decisively through its dynamic force engine family. But while these power plants are already among the most thermally efficient and performance-optimized ICEs on the market, their story is far from over. Rather than abandoning combustion engines entirely, Toyota is refining them to work smarter, cleaner, and more efficiently, often in partnership with electric drive systems. The dynamic force engines are no longer just a standalone solution. They are becoming a core component of Toyota's broader electrification strategy. And in this phase, the goal isn't merely fuel savings, it's total ecosystem integration. Toyota's engineers have been transparent about the direction of their R&D. If ICE is to coexist with electrification, it must evolve rapidly. Dynamic force engines are already optimized for high-speed combustion, low friction, and ultra-lean burn, but future iterations aim to push efficiency even further. Current dynamic force units, like the A25 AFXS and M20 AFXS, already hit 41% to 43% thermal efficiency in hybrid applications. However, the company's advanced development goals stretch beyond 45%, which would set a new benchmark for mass-produced gasoline engines. This would be achieved through further combustion optimization, higher expansion ratios, low energy loss valve systems, and next-gen intake technologies. New experimental engines under the dynamic force umbrella are rumored to include variable compression ratios, integrated thermal management systems, and low-temperature exhaust gas recirculation. All of these elements are designed to extract more power from less fuel and with fewer emissions. These advances are critical, not just to maintain Toyota's reputation for efficiency, but also to ensure its hybrid systems can outperform full electric competitors in real-world scenarios, especially in markets where charging infrastructure remains weak. Toyota's hybrid dominance has always hinged on the seamless marriage between ICE and electric motors. With the latest generation of dynamic force engines, Toyota has laid the groundwork for even tighter integration in its hybrid systems. The next wave of Toyota hybrids will not only feature more powerful motors and lithium-ion battery packs, but will also rely on engines that are specifically designed to operate at ideal points on the efficiency curve. Rather than being a generalized power source, future dynamic force hybrids will act as range-optimized power plants, working in harmony with predictive energy management systems, geofencing algorithms, and real-time traffic data. This means that the ICE might remain dormant in city centers and activate only during high-efficiency cruising conditions, a setup already tested in Toyota's plug-in hybrids and being adapted to standard hybrids. Toyota's dynamic force engine isn't just a technical upgrade. It's a statement, a reminder that the internal combustion engine still has fight left in it, and Toyota isn't ready to give up its crown without a battle. As rivals rush toward full electrification, Toyota is quietly building something far more strategic, far more calculated. But in a rapidly changing auto industry, will this bold engine be remembered as a masterstroke or a missed opportunity? Let us know your thoughts below. Don't forget to like and subscribe.